Okay, so cubic function. What is the degree of a cubic function? 3. Okay, so we're going to write 3 for that. And I know your graphs are on the previous page. You don't have to look at your notes. You can just look at my graphs right here. What's the degree for the quartic? 4. Degree for the quintic? 5. Looks like some of you have already answered all of them. Good job. Now look at your graph of the cubic. How many x-intercepts do you see? 3, right? 3 x-intercepts. Remember, we talked about the x-intercepts. You can have at most. The word at most means up to that degree. Can I have less than that? Yes. Okay. I can have no x-intercept. So be mindful of that. On the quartic, how many x-intercepts? Just 2. Can you guys see that? One's right here and one's over here. Okay. So we have 2. Can you see that it doesn't have to be the same as the degree? It's up to 4. That doesn't mean that I have to have 4 all the time. How about the 5th degree function? How many zeros do we see? 5. So this one happens to be the maximum x-intercept. Now, the cubic, how many turning points? Okay, turning points, meaning that the location that I'm about to change direction. I'm going up, and then also I'm going down. So one turning point's right here, another one's right there. So turning point is 2. Turning point you can have at most. Okay, at most 1 less than the degree. So the degree is 3. The most turning points you can have is 2. Now how about the quartic? How many turning points do we see? 3 of them. Okay. So turning point is at most 1 less than the degree. How about the last one? How many turning points is that? 4. Okay, remember turning points can also be called the maximum or the minimum. This is a max, that's 1 turning point. This is a minimum, that's another turning point. That's a max and that's a min. So those are the turning points. So the turning points could be 1 less than your degree. Now let's talk about the end behavior. As x, for the cubic, as x approaches a negative infinity, so does that mean I'm going left or going right? Left. As we're going left, what's the behavior for y? Yeah, y is going downward, y'all. So this is negative infinity, infinity. So we are going to verbally spell it out for these, and then once we get really good, we're not going to need to spell it out. So verbally, we're going to say as x approaches, y also approaches, with this question, negative infinity. And we will also do the limit notation. So we are going to write the word limit as x approaches negative infinity. What did they use for y? What variable did they use for y for this question? F of x, okay. Y also approaches negative infinity. So that's your end behavior. Let's answer the right end behavior at the same time. As x approaches positive infinity, okay, as x is going to the right, what's the behavior for y? Is it going down or up? Up. So we can answer both at the same time here. So as x is approaching positive infinity, y went up. So verbally, we will say as x approaches positive infinity, y approaches positive infinity. And limit notation. Limit as x approaches positive infinity, y, which we are using f of x, equals infinity. And then we'll roll back up to look at the middle graph to answer the other half. Okay. So here's the quartic. We will answer both end behavior at the same time. As x approaches negative infinity, what's happening to the y? It went up, right? So y approaches positive. As x approaches positive infinity, what's happening to y? It also went upward. So both end behavior right? The right end behavior, which is to the right, and the left end behavior, they were both what? Positive infinity. Okay? So we will answer both at the same time. So as x approaches negative infinity, y was approaching positive infinity. So verbally we will say, as x approaches negative infinity, y approaches positive infinity. Your limit notation, limit, as x is getting really, really big towards some negative infinity, y, which is f of x, was approaching what? Infinity. Okay. Now we answered the right side at the same time. With this graph, as x was going to the right, where was y going? Up or down? What was it? Up. Okay. So as x approaches infinity, which is the right side, y approaches. Good morning. Thank you. Infinity. And limit is going to be x approaches the right side, which is infinity. Y came out to be infinity. Okay. I would like for you in your team to accomplish the last graph. Okay. Answer the end behavior for your last graph. So I need you to answer all of the questions on that last graph, okay? Once you're done, I want you to talk to your team and compare your answers. Okay, here we go. Answer number 1, okay? As x approaches negative infinity, Quist, y approaches what? On the quintic. Y approaches negative infinity. Did you guys agree, Quist? Yeah. We're not going to verbally spell it out. The reason I spell it out verbally so we know what to say, but you will need to know how to do the limit notation. So limit as x approaches negative infinity, y was approaching negative infinity as well. Dahlia, can you tell me the answer too? As x approaches infinity, y was going where? To go pause infinity. Do you guys agree, Dahlia? Okay. So guys, write down the limit notation. Limit as x approaches the right side, which is infinity. Y was approaching infinity. Okay. Now, I'm going to ask you, what are some patterns, okay? What are some patterns you notice about the graph and the equation or the degree themselves. So let's go up, bless you. Okay. Let's start with constant. Okay. Constant has a degree of what, class? 0. Okay. Are there any turning points on that? No. Okay. Linear. Nathan, linear has a degree of what? You can talk to your friend. Ask your friend what the degree of linear is. 1. Is 1 an odd number or an even number? An odd number. Look at the end behavior of linear. Is it going opposite directions or the same direction? Opposite, right? One's going up, one is going down. Next graph is called a what? Alyssa, what's the third graph we have on here? Good. What is the degree of the Malin? What's the degree of the quadratic equation? No, not 4. Degree means the highest exponent. 2. Look at the end behavior. Is it going opposite directions, like the number 1, linear, or is it going the same direction? Same. So far, so good. Okay. Move on to the last 3 here. The next one is the cubic. Cubic has, Diego, how many degrees is the cubic function? Cubic function, Diego, hon. How many degree? What's the highest exponent? I can't hear you at all. I'm old. You have to speak up like I... 3, yeah. Now look at the end behavior. Is it ending the same way? No. They're going opposite ways, right? Quartic, Riley, quartic has how many degrees? We're on the quartic function. So how many degrees? 4. Look at the end behavior, class. Is it ending the same way? No. What's the pattern so far? Yes, class. Listen to Wyatt. He knows. If the degree is odd, your end behavior will be opposite. If the degree is even, it's either going up or down. Let's spell that out. Okay. Because it says, what do you notice? So that's one pattern, and then we'll spell out some more. Okay. Odd degree. Wyatt, if it's odd degree, does it end the same way or opposite way? Okay. Ends opposite ways. Bless you. If the degree is even degree, same end behavior. Okay. It will end the same way. Now let's talk about the number of real zeros, so the number of X-intercepts. If you guys have, how many X-intercepts, so how many real zeros can you have? More than the degree or less than the degree, or at most the same as the degree? Right, at most the same as degree. Okay, so X-intercept will be at most the same as the degree. How about end behavior? At most the same or more or less? 1 less. Good job. Okay, so I'm sorry, did I say turning points? Sorry, I meant turning points. Turning points will be 1 less. 1 less than the degree. Okay, that will kind of help us a little bit because we're about to answer these right here. Let's pretend that if you can't see it, let's pretend that touches, okay? When I sketch these out on Word, sometimes it cooperates and sometimes they don't. So this example says use those 3 graphs. to answer all of these things that we just got done learning. Graph A. What is the end behavior? As x approaches negative infinity, what's y? Positive infinity. As x approaches positive infinity, what's y? Also positive. I don't need you to write down the verbal unless you are you don't know what that means, then you can write the verbal. I do need you to write out your limit. Okay. So limit notation would be limit as x approaches negative infinity. Can you guys see that this is not an equation? So what variable would you like to use as a class to represent y? F of x of y? Okay. So the limit as x approaches negative infinity, your equation y equal to infinity. And we answer the right side the same way. As x approaches infinity, y was approaching infinity, right? So limit as x is approaching positive infinity. Can I use f of x if you like f of x better? Yeah, you can use y or f of x, or g of x or h of x. How many real zeros does this first graph have? How do we answer that? Real zeros, meaning where it crosses the x-intercepts. You're right. So how many times did it cross or touch? 3. We have 3 real zeros. Okay. We have 3 real zeros. Now let's go back. How many turning points do we see? Okay, so I know 1's right there, 2's right there, and 3's right there. Do you guys agree with that? Okay, 3 turning points. Oh, what could be a possible degree of graph A? How do you know it's 4? Yeah, the turning point is 1 less. So if it's a 3 turning point, now also look at the end behavior. Is it the same or opposite? That means it has to be an even degree. Would you guys agree? So you can use 4, you can use 6, you can use 8, you can use 100 even. Okay, but usually I use the next highest one. Okay, so that could possibly be a 4. Okay. All right, let's do graph B, and then I'm going to ask you to do graph C on your own. Graph B, end behavior. This one goes to Naomi. As x approaches negative infinity, hun, y approaches? Good, and we're going to write the limit. So limit as x approaches negative infinity. I'm going to use f of x. Y or f of x equals negative infinity. Okay. Next, Sophia H. As x approaches positive infinity, hun, y is approaching? Very good. So negative infinity. So limit notation, limit as x approaches positive infinity, f of x is approaching negative infinity. How many real zero? Slater, graph B. How many real zero did you see or does it have? You're right. None, 0, or none. Okay. It never really crossed the x-axis. How many turning points? Mariana, how many turning points does graph B contain? 2. Mariana said 2. No, wait, okay. 1, 2, and 3. Okay, so good. Good correction. Now look at the end behavior. Does it go the same way or opposite way? Same. That means the degree should be odd or even? Even. So what degree is a possibility here? 4. You're right. Okay. All right. I would like for you to take 2 minutes in teams or on your own to execute the last graph. Okay. right, Kenzie, graph C, okay? As x approaches negative infinity, what's the end behavior for y? Positive infinity, okay? So limit notation. Malin, what's your limit notation? What did you write? You mean limit, right? As x, arrow goes where? Not this one. Uh-huh. And then you write f of x equals 2, positive. Okay. Then next one. As x is going to the right side, Wyatt, what's the end behavior for y as x is going to the right? As x approaches infinity, what's y? Negative infinity. Limit notation, okay? That's okay. Limits, What else do we write? What's under the word limit? X is going to infinity, What else? Y equals negative infinity. C says how many real zero? Brandon, how many real zero? Oh, I can't speak. How many real zeros? 2. Let me check. You guys agree with Brandon? Yep. 2. How many turning points? Okay, Hannah, how many turning points? Also 2. Do you guys agree so far? Now, look at the end behavior. Look at the end behavior. Are they going the same way or opposite ways? Odd then or even degree? Odd. So what is a possible, Grace, degree for the third graph? Beautiful. Okay. So that's an introduction to your polynomials. Now we are going to graph it. Now I'm going to give you the graph equation and you're going to sketch them out. Okay. Ready? Graphing polynomial functions. First, we need to know how to determine the end behavior. Do they go the same ways? Do they go opposite ways? Okay. If it's an even degree and you have a positive a value, okay. If it's an even degree and you have a positive a value, such as, I'm going to give you some basic equations, like 2x to the 4th. Is that an even degree? What's the degree? Great. What's your a value? 2. A is positive. You will have a graph that goes like that. That's just a sketch, okay? So, look at your end behavior. Are they both going up or down? Up. So as x approaches either negative or positive infinity, y approaches what? Infinity, right? Because a is positive, it opens upward. Therefore, both y's will go towards positive infinity. Now, if it's an odd degree, like y equals 2x to the 3rd. What's the degree here? 3. What's your a value? 2, still positive. Do you guys remember? You guys just took a quiz on cubic. Doesn't it look something like that? Okay. Now let's think about it. If x is approaching negative infinity, what is the end behavior for y? Negative infinity. If x is approaching positive infinity, what's the end behavior for y? Infinity. Okay, so as you can see, odd degrees, they don't behave the same way. Now, what if a is negative? Like y equals negative 4x squared. What's the sketch of that? Right side up or upside down? Upside down like that, right? So, a is negative 4. What's happening to the end behavior? As x approaches either positive or negative infinity, y is approaching negative infinity. Okay. And same thing with odd degree. I'm going to give you y equals negative 2x to the 3rd. If it's negative in the front, Can you guys agree that there's a reflection over the x-axis? It reflects over the x-axis. What used to be on the top is now on the bottom. So would you agree that it's going to go like this? Yep. So as x is approaching negative infinity, what's your y behavior? It's positive. X is approaching positive infinity. What's your y behavior? That's right. Okay. Now, guideline number 2. First, you determine the end behavior. Do they go the same way? Do they go the opposite way? Next, to sketch out your graph, find the zeros. Zeros is another word for x-intercept or the roots. Okay? So if you see the word x-intercept, real zeros or root, they mean exactly the same thing. Okay? Are any of them double, aka an even multiplicity? Then by definition, it touches the x-axis. Any root that has an odd multiplicity, it crosses the x-axis. That's confusing, huh? Okay, so let me give you an example. And you don't have to, I want you to understand this more than anything, okay? The third one is just obviously sketch. So, you guys just took a quiz on cubic. So I'm going to give you -1 times x minus 2 cubed. Do we know a? What's your a value? -1. What's your h value? 2. What's your k value? That's right, because I didn't write anything, so we're going to say 0. If I were to sketch this out, would you agree that I will have +2, 0, which is right there? Right? Just a little sketch. You don't need to, just understand it. Would you agree, because it's a -1, I will start over here and go downward? Would that be a true statement? Versus, I'm going to do another example. We can see the difference between the two, okay? X minus 2 to the third. Can you guys see that? I mean square. I just used square. Okay, a is still -1. True or false? H is still 2. K is still 0. But obviously it's not a cubic. So, what shape is this? Okay, U. Would you agree I have a vertex here and it opens like that? I'm going to hold it tight. Would you agree with the two graphs? Now, this is what it's saying on that guideline number 2. The root, aka the x-intercept, if it's double is 2. 2 is also called an even number. If it's double or it has an even multiply, can you guys see that's an even number? Would you agree that x minus 2, this has 2 of those? When you have multiple of something, wouldn't you agree that it's called multiplicity or multiples? Okay, so it has 2 of those. That's why it's called a even multiplicity. Can you guys see that this is just touching the graph? I mean, just touching the x-axis. If it has an odd multiplicity, that means there's 3 of them, or 1 of them, or 5 of them. Guess what it's doing to the x-axis? It runs through it, okay? So, if it's an even multiplicity, it bounces off, okay? AKA just touches it and curve back down, or touches it and curve back up. But if it's an odd degree, then it runs through it. And that, we need to know that, so that way when we sketch it out, we need to know, hey, do I bounce it off, aka touch it, or do I run through it? Okay. Any questions on that language? Okay, let's practice 1, 2, and 3, and then see what time we have left. Examples 1, 2, 3, and 4, and 5. It says sketch a graph, and then for each one of those. Success is if we can finish examples 1, 2, and 3. First, we want to know the degree of this. What's the degree of example 1? How do you know it's 2? Yeah, If you were to ask, if I were to ask you, FOIL this out, what's the highest exponents? 2. So that's a degree 2. Is that even or odd? That means you go either this way or this way. Now we have to look for an A value. Is A positive or negative? Positive. How do you know? Yeah, the x's are both what? Positive. So A is positive, and it's bigger than 0. So now do we know for sure how it opens? This way, right? Can I find the x-intercepts right away? Can I find the zeros? Can I find the roots right away without doing much work? Yeah. The root or the zeros or the x-intercepts. All you do is just take the y and set equals to. It's already factored for you. So you have 2 roots. One is at x equals. The other one's at x equals. What's the first root? 5. Take the first factor. You said it goes to 0. It was 5. Take the next factor. You said it goes 0. What's the second root? Negative 9. Okay, let's go and plot. Plot both x-intercepts, please. One's at 5. 2, 4, 5. One's at negative 9. Okay. Do we know the end behavior? They're both going upward, downward, or mixture? Up. So we start with end behavior because it said so. Now, do I bounce off each root or do I run through it? Is this a degree of 2 or is each one a degree of 1? 1. Is that an odd number or even? 1 is odd. So if it's odd, I would run through the x-axis. Would you agree? That's running through. That's also running through. So what shape is that? That's a parabola. Because a parabola will give me a degree of what? 2. That's all we got to do. Okay. Number 2. What is a degree? Is 2 a degree of 3? It's 4. How do you know it's 4? That's right. A value. It's A negative or positive? All the x's have a leading coefficient of 1, right? And they all happen to be positive. How many roots do we have? How many factors do you see? How many factors do you see? 3. That means you have how many roots? 3, right? What's your first root? 0. Take x, set equals 0, that's 0. X minus 1, set equals 0. What's the second root? 1. X plus 8, take that, set equals 0. Negative 8. Okay. Let's plot the roots. 0's one of them. 1's one of them. Negative 8 is the other. What's your end behavior? Do I go up, down, or mix? They're both degree of 4, so shouldn't they be going the same way? A is positive, so do I go up or down? Up. So start with the end behavior. Okay, now, at negative 8. Negative 8's over here. Is that a degree of 1 or degree of 2 or 3 or 4 or 5? What degree is that? 1. Is that an odd degree or even degree? Odd. So do I cross or do I bounce? Cross. Okay. So I will cross at negative 8. So far, so good? At 1. What degree is that? 2. So do I cross or bounce? Ah, okay. At 0, what degree is this? 1, 2, 3, 4, 5. 1. So do I cross at 0? Yes. Okay, so here we go. Would you agree? I knew I just crossed that. This I need to cross at 0. True or false? Then at 1, I bounce off, right? Or just touch it. So would you agree that I'm something like that? Okay, I'm going to make it a little bit prettier. Okay. So would you agree that I just bounce it off at the one location? Yeah. And that's all we got to do when we are sketching. Okay. Last graph. What is the degree of this last one? 3. Ooh, it's an odd degree. Do we end the same way or opposite way? Opposite. A, negative or positive? There's a negative in the front, so it would be negative. Okay, less than 0. How many roots? 3. What's your first root? Negative 2. What's your root number 2? What's your third root? 5. Okay, go ahead and plot the roots. Negative 2, negative 7, and how is that? 2, 4, 5. All right. Now we're going to do the end behavior. If it's a cubic and it's a negative a, would you agree that it looks like this? So, if we know what it looks like, we can start with the end behavior right away. Okay. Now, look at each root. Does each root have any even multiples? No, that means it will cross through each and every one of those. So that means I'm going to run through, and run through. And that's an egg roll for J. We will pick up. So class, did you guys fix this one? Shh. Okay, fix that for me, okay? That's supposed to be 0.